welcome to another geography class. My name is Sonia Ekeleme. Our theme for today is Environment and its Resources, and our topic for today, Climate 2 Part 1. Before we go into our class proper, let's take a look at the lesson objectives. By the end of this class, you should be able to identify climatic factors and explain the effect of these factors on weather and climate. Now let's get into our lesson proper. The climatic condition of different regions of the world where we live in is affected and shaped by several factors that come to play. These factors are known as climatic factors. The climate of a region or a place is also not formed at an instant. There are several factors that come to play, and these factors will determine the kind of climate in any region. Like I said earlier, certain factors affect the climate of regions. Now, what are climatic factors? Climatic factors are a host of interacting factors or elements that can shape or determine the kind of climate a region will experience. Let's take a look at some of them. Some climatic factors include the following: latitude or distance from the equator, distance from the sea, relief or shape of the land, direction of winds, human activities, and vegetation. Let's go through them one after the other. The latitude is a line that shows the distance of a location or a place from the equator. It is also used to determine the position of a place on Earth. Latitude determines to a very large extent the climate of a region. The equator is a major line of latitude. Regions that are very close to the equator will experience hotter and warmer climates, while regions that are close to the poles will experience cooler climates. For example, countries like Ecuador, Somalia that are close to the equator will experience warm weather and climates, while countries that are close to the poles, such as Norway and Russia, will experience colder or cooler climates. This difference in climatic conditions is as a result of the tilt of the Earth at 23.5 degrees. Because of this tilt, areas that are close to the poles stay very far away from sun rays. This makes them cold, while areas close to the equator that have direct sunlight all year stay warm always. This is an image showing the position of the equator and the direction of sun rays. From the image, we can see that areas located far from the equator hardly get enough sunlight, while areas very close to the equator receive sunlight all year. A second factor that can affect the climatic condition of a region is distance from the sea. How close an area or a region is close to the sea or a body of water determines to a large extent the climatic condition of that area. Regions that are far from the sea or a body of water will experience warmer climates as a result of less precipitation, high temperatures, dry winds, low humidity, etc. While regions that are close to bodies of water will experience cool climates. This is because the body of water surrounding them helps to reduce their temperature and increase the humidity, also leading to enough cloud cover. The first image shows a dry land, an area very far from a body of water. From the image, we can see that the area has very little vegetation because of low precipitation, while the second image shows an area close to a body of water. From the image, we can see the thick cloud cover found in that area. Relief or shape of the land. The shape or topography of a region affects the climatic condition of that region. The higher the elevation of a place, the colder the weather and climate of that region, while the lower the elevation of a place, the warmer the climatic condition or weather condition of that area. High terrains or mountains block the flow of air. When warm air comes in contact with a high terrain, it is forced to rise along the slope of that high mountain or a high terrain. When the warm air rises along the slope, it cools down. The cooling is also known as adiabatic cooling. This cooling results in the formation of clouds, and we know that clouds lead to precipitation in forms of rainfall and snow. The side which the cloud is located or positioned at is known as the windward side of the mountain. As the rising air gets to the summit or top of the mountain, it is stripped off of its moisture. The other side of the mountain is known as the leeward side of the mountain. This is the part of the mountain that experiences dry climate as a result of the stripping of the moisture from the air. In this region, air begins to warm up. It is also known as adiabatic warming. The schematic diagram shown on the screen explains the effects of relief or shape of the land on climate. From the diagram, we can see that the windward side has lots of vegetation, while the leeward side has little or no vegetation. It is important to know that adiabatic cooling leads to the growth of vegetation, while adiabatic warming leads to the loss or no vegetation. These are images showing mountainous areas. Now let's take a look at the effects of direction of winds on the climate and weather of a region. Winds can affect the amount of precipitation received by an area depending on where they are blowing from. It can also affect the weather and climate depending on the amount of moisture it is carrying. Winds blowing from dry and arid regions like deserts will carry dust and high temperature air, while winds blowing from oceans or cold regions will lower the temperature of the region. Human activities. We'll take a look at the effects of human activities on weather and climate. So many activities of humans have led to changes in the weather and climatic condition of regions. For example, the burning of fossil fuel in industries and even in cars can affect or increase the quantity and amount of carbon dioxide in the atmosphere, leading to global warming. The first image shows a gas flaring site. This causes increase in carbon dioxide concentration in the atmosphere as a result of the carbon that is emitted into the atmosphere. Secondly, the cutting down of trees or deforestation has led to an increase in the concentration of carbon dioxide in the atmosphere. This has affected the climatic condition of regions. Trees serve as traps for carbon dioxide, and when they are cut down, they give out carbon dioxide back into the atmosphere. This has led to changes in climate and weather conditions of regions. During the pre-industrial era, that is before industrial revolution and even the use of so many cars, the climate then was more conducive and cooler. This is because carbon dioxide had little concentration in the atmosphere. But as you can see today, the number of industries and cars have increased, leading to an increase in the concentration of carbon dioxide in the atmosphere, thereby affecting the climatic condition of regions. Also, the activities of humans which have led to changes in the climate has led to an increase in extreme events such as hurricanes, heat waves, tornadoes, etc. Human activities that has led to climate change has caused an increase in the surface temperature of the earth. This has led in thermal expansion and melting of ice that has led to rise in sea levels. Lastly, vegetation can affect the weather and climate of a region. Just as climate can affect the type of vegetation in the region, vegetation can also affect the type of climate or weather condition in the region. Regions with much trees and vegetation will have more water vapor in the atmosphere. This will make the region cooler. Also, in some regions that have grassland and savannas, the vegetation can help provide the atmosphere with little water vapor that can help in the growth of little vegetation. During the process of photosynthesis, plants release water vapor into the atmosphere. This released water vapor leads to the formation of clouds. And clouds can also affect the amount of sunlight an area receives or the amount of precipitation an area receives. Plants, during the process of transpiration, which is the giving out of water vapor through the pores on the leaves of plants, can affect the humidity and temperature of a region surrounding the plants. From the image, we can see the droplets of water on leaves of the plants. This can help plants regulate their own weather by creating a micro-weather around them. Also, the process of photosynthesis affects the climate of a region. This is because during the process of photosynthesis, plants can give out oxygen. This has led to a 21% concentration of oxygen in the atmosphere from which we benefit from as humans. Plants take in or use carbon dioxide during the process of photosynthesis. This helps to reduce the concentration of CO2 in the atmosphere. This has helped in reducing the amount of greenhouse gases in the atmosphere, which was formed as a result of the burning of fossil fuels by humans. We've come to the end of this lesson, but before we go, let's take a quick rundown of what we learned during the lesson. We learned that climatic factors, to a large extent, determine what to be expected in the climate of any region. We also learned that some climatic factors include latitude or distance from the equator, distance from the sea, relief or shape of the land, direction of winds, human activities, vegetation, etc. And lastly, we learned that climatic factors differently affect the weather and climate of any region. Now let's test ourselves with some few questions on our knowledge of our understanding of the lesson. Question 1. Which of the following is not a factor affecting the climatic condition of a region? A. Latitude or distance from the equator. B. Distance from the sea. C. Quantity of rainfall. Or D. Relief or shape of the land. The correct answer is C. Quantity of rainfall. Question 2. The effect of air getting cooled as it is lifted up along the mountain slopes of high terrains is called A. Atmospheric cooling, B. Asymmetric cooling, or C. Adiabatic cooling. The correct answer is C. Adiabatic cooling. I hope you can now identify climatic factors and also explain the effects of these factors on weather and climate. See you in our next class. Bye.